Hello and welcome to Algebra 2 Test Section 1 on composition of functions. All right, so the problem we're going to look at today, we have g of n is equal to 4n minus 1. We have f of n is equal to 2n minus 5. And what we want to find is g of f of n plus 4. So the first thing we're going to do, we're going to work on f of n plus 4. We'll figure out what that is, and then we'll come back and find g of that. So f of n plus 4. What does that give me? Well, I'm just substituting an n plus 4 in everywhere I see an n. So I would have 2 times, plug in the quantity n plus 4 there, then minus 5. So this equals 2 times n is 2n, then plus 2 times 4 is 8, then minus 5. So 8 minus 5 is 3, so I can say this is 2n plus 3. Okay. So if we know that f of n plus 4 is 2n plus 3, what I can say now is g of f of n plus 4 is really g of 2n plus 3. So that makes this very, very simple. Let me erase this so we have some room. And all I want to do now is I just want to plug in a 2n plus 3 everywhere I see an n in g of n. So basically just right here. So I would have 4 times, where I see the n, I'm plugging in a 2n plus 3, and then I'm subtracting away 1. So 4 times 2n would be 8n, and then 4 times 3 is 12. So plus 12, and then minus 1. So what happens is we have 8n, and then 12 minus 1 would be 11, so plus 11. So g of f of n plus 4 is 8n plus 11. Hello and welcome to Algebra 2 Test Section 2 on composition of functions. All right, so we're going to take a look at g of n is equal to 3n minus 3, h of n is equal to 4n minus 3, and we're trying to find g of h of 2n. So all I want to do here is very, very easy. I want to start by finding h of 2n. So if I had h of 2n, what is that asking me for? It's asking me to plug in a 2n everywhere I see an n in this function h of n. So this would be 4 times, instead of n, I would have 2n, and then minus 3. So 4 times 2n is 8n, so you'd have 8n minus 3. So I know h of 2n is 8n minus 3. So I can really say that I want to find g of 8n minus 3. So what is that? Well, all I'm going to do is plug in an 8n minus 3 everywhere I see an n in g of n. So I would have 3 times this guy right here, 8n minus 3, just plugging that in for n there, then minus 3. So what does that give me? Well, I use my distributive property. 3 times 8n is 24n, then minus. 3 times 3 is 9, then minus 3. So you'd have 24n. Negative 9 minus 3 would be negative 12, so you could say this is 24n minus 12. So you could say g of h of 2n is equal to 24n minus 12. Hello and welcome to Algebra 2 Test Section 3 on composition of functions. All right, so we're going to take a look at f of x equals x minus 2. G of x is equal to negative 2x minus 1. And we want to find f of g of x over 3. So the first thing I would do is find g of x over 3. So if I came over here and said, what is g of x over 3? All I'm going to do is I'm going to plug in an x over 3 everywhere I see an x. This is equal to negative 2 times, again, I'm going to plug in an x over 3 in for that x, and then minus 1. So this would end up just being negative 2x over 3 minus 1. Now you can get a common denominator there if you want. You don't have to. I'm just going to leave it as it is. And so this guy right here is what g of x over 3 is. So that's what's going to go there. So I want f of this. So really I could just rewrite this and say that I want to find f of negative 2x over 3 minus 1. So what does that mean? Well, if I go into f of x and I say everywhere I see an x, I want to plug this in. So I would say I have negative 2x over 3 minus 1, and then I'm subtracting away 2. So essentially I have negative 2x over 3 minus 1 minus 2. So negative 1 minus 2 is negative 3. So you might as well just say this is minus 3 here. And that is my answer. If I wanted to get a common denominator, I could say this is plus negative 3. I could multiply this by 3 over 3. And I could say this is negative 2x. Negative 3 times 3 would be negative 9. So I could say minus 9, then over the common denominator of 3. So f of g of x over 3 is equal to negative 2x minus 9 over 3. Hello and welcome to Algebra 2 Test Section 4 on composition of functions. All right, so we're going to take a look at f of a equals 3a plus 1, g of a equals a cubed plus a squared, and we're trying to find f of g of a over 3. So what is this going to be? I'm going to start with g of a over 3, and I'm going to find that. So g of a over 3, I'm just going to plug in a over 3 in everywhere I see an a. So this would be equal to a over 3 cubed plus a over 3 squared. So what would that give me? This would be a cubed over 3 cubed, which is 27, plus this would be a squared, and it looks like a 9, so let me make that a little better. So a squared over 3 squared, which is 9. So I have a cubed over 27 plus a squared over 9. Now I could get a common denominator going if I wanted to. You don't have to, so I'm just going to leave it as it is for right now. And so g of a over 3 is this. So I can really say what I'm trying to find here is f of a cubed over 27 plus a squared over 9. Let me make that a little bit better. So this is equal to what? All I'm doing is I'm plugging this in for a here in this f of a. So this would be 3 times this guy. So this is a cubed over 27 plus a squared over 9 and then plus 1. Okay, let me scroll down and get a little room going. So if I multiplied 3 times a cubed over 27, what would happen? This would cancel with this and give me a 9. Then we'd have plus, if I had 3 multiplied by a squared over 9, this would cancel with this and give me a 3 here. And then, of course, we have that plus 1. So I would have a cubed over 9 plus a squared over 3 and then plus 1. Now, you could get a common denominator going if you want to, or you can leave it like this. This is perfectly acceptable. A cubed over 9 plus a squared over 3 plus 1. If you did want a common denominator, you'd multiply this by 3 over 3. So you could have a denominator of 9, and this by 9 over 9. So that would end up giving you a cubed plus 3a squared. Let me make that a little bit better. Then plus 9 over the common denominator of 9. So that would be your answer if you wanted a common denominator, one single fraction, a cubed plus 3a squared plus 9 over 9. Hello and welcome to Algebra 2 Test Section 5 on composition of functions. So suppose we see f of n equals n cubed minus 4, g of n equals n minus 1, and we want to find g of f of n over 2. So what are we going to do first? We're going to find f of n over 2. So f of n over 2. So that's going to be equal to what? Well, I take f of n, and I just plug in an n over 2 everywhere I see an n. So here's an n there, so I would plug in n over 2, and it's cubed, and then minus 4. So this would end up giving me n cubed over 2 cubed is 8, and then minus 4. Now, you can get a common denominator going if you want. I'm just going to leave it as it is. So this right here is what this is, right? F of n over 2 is n cubed over 8 minus 4. So I might as well say this is equal to g of n cubed over 8 minus 4. Now I can erase all this. I don't need any of this anymore. So what would this give me? Let me kind of drag this up. So this basically tells me I'm going to plug in an n cubed over 8 minus 4 everywhere I see an n in the function g of n. So I would just have n cubed over 8 minus 4 and then minus 1. So negative 4 minus 1 would be negative 5. So I can say this is n cubed over 8 minus 5. if I wanted to get a common denominator going, I could say this is n cubed minus, I'd multiply the 5 by 8 over 8. 5 times 8 is 40, so this would be n cubed minus 40 over the common denominator of 8. So either n cubed over 8 minus 5 or n cubed minus 40 over 8.